So here's the idea behind area models. I have this legend here that shows what each shape is weighted as. So a square is weighted as x, blue square. Red square is weighted as negative x, same idea down here. So with an area model, or not an area model, a hanger diagram. So area models are a whole other thing, ignore that. It's basically a balanced hanger. So everything on this side is equal to the weight of this side. So we're saying we have this balanced hanger below modeling this equation. We're going to make moves to isolate one blue square that represents x in order to determine the weight of x. So right now we have 3 red squares representing the negative 3x and 1 blue square representing 5. And over here we have 1 red circle representing 5 and then 3 blue circles representing 3. So that's a total of 8. All right, so we got to isolate 1 blue square. I have 3 red squares, so I don't want them to be blue anymore, or to be red anymore. I want them to be blue. So to undo those 3 red squares, I have to apply their opposites. So I'll stack these on top. I'm just copy and pasting, Control C, Control V, boom, super quick. Kids can do this on a computer just like this. All right, so now here I have 3 blue squares added to this side. Unfortunately though, I just unbalanced my hanger. Since I did that to this side, I now also have to add 3 blue squares to this side. So I'm going to paste 3 blue squares over here. All right, so I've got 3 blue squares here, 3 blue squares there. So what I like to do is have them keep a running log of what they're doing. So here they just took negative 3x plus 5, and all they did was add 3x. So we'll have the plus 5 still. We'll have that negative 3x still. So to both sides, we're going to add 3x. So we put 3 positive x's down. All right, so that's what they've done so far. Cool thing now is these undo each other. They become 0. It's important that they understand that this is 0. So now those are gone. Well, I can just delete them all. These 2 get deleted. These 2 get deleted. These 2 get deleted. They're gone. And I can erase my zeros. So now I have a new equation. 5 is equal to 8 plus 3x. And I have them right back. So I've got 5, and they can see hopefully negative 3x and 3x is 0 is equal to 8 plus 3x. And if they want, they can write a statement saying what they did. They added 3x to both sides to undo the negative 3x. All right, still I don't know what 1 blue square is equal to. I need to get them all by themselves. So let's get rid of this 8 right here. So to do that, I'm going to get 1 red circle to cancel out or undo that blue circle. I also need 3 red triangles. These 3 red triangles on top. And again, these become 0. If they want, they can sit here and cross them out and say they become 0. But that gets a little tedious. They should know now that these just delete themselves. So now we can write the equation that we have. I actually forgot to add 3 red triangles to this side as well, though. We'll have 3 red triangles over here, 1 red circle over here. So whatever we do to one side, we have to do to the other side. All right, and now this hanger is balanced again. I had unbalanced it when I added to this side, so I had to keep it balanced by adding to that side. And now I can write what we have. We have 5 still on the left side, but what we did is we added -8 over here. That was the red circle and the 3 red triangles. Same thing on this side. We have 8 plus 3x. And to that 8, I had subtracted 8, the 3 red triangles and the 1 red circle. So now we can remove these. These are opposites. They undo each other, so they're gone. Same thing here. Those are gone. These are gone. These are gone. Now you look on this side, I have a red circle and a blue circle. Those are gone. Now all we've got left is 3 red triangles on the left and 3 blue squares on the right. So now we can write what we have in our next step. Our new equation is -3x, or -3 is equal to 3x. So we have -3 is equal to 3x. So this might be the tricky part for them, but we wanted to know what one blue square was equal to. Well, look. This blue square can correspond with that red triangle, this blue square with that one, and this blue square with that one. This is basically saying now that we've divided this into 3 groups. I have one group, and one group. This is literally division. I divided 3 into groups of 1 blue square. And we can see that this blue square that's x is equal to 1 red triangle that's -1. So here, all we did was take our equation and divide it by 3x. Or sorry, divide it by 3. So I had -3 is equal to 3x. And I divided both sides into 3 groups. This meant that we had 1x over here is equal to a -1. Coefficient of 1 is unnecessary, so we can erase it. And it's just x is equal to -1. And we can see that in our hanger diagram. And now I have the running log of everything I did, solving step by step without any magic tricks, just a tool to visually and kinesthetically aid what we were doing. Eventually, after we've set up models like this, we can have them just have an equation and build their own equation to start with and continue to solve. Once they start to understand the ideas behind what you do to one side, you do to the other side, they've now formalized the idea of inverses when we're solving equations. That's my idea behind it. That's why this makes sense mathematically. No magic involved, no bubbles, no nothing like that. It's just math.